Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I'm Shubhi Gupta and part of the data science team at Analytics Vidhya, and I will be the moderator for this session along with Tamil and Shresh. For those who have joined us for the first time, a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya led by top industry experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. As the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be great source of enrichment and value adding for our community members. Now on to our session today, which is hands-on with social network analytics. In this data hour, the speaker will break down the essentials of what you need to know about social network analytics, how to learn SNA, and where you can study SNA post the webinar as well. I hope you are excited to attend this webinar with us. Now, on to our speaker. In this session of Data Hour, we have Emilka Vidhana with us. Amilka Vidhana is the head of competency excellence in the field of data science, senior architect at ADA. He has 15 plus years of experience in the ICT and finance industries with broad knowledge and hands-on experience in artificial intelligence, machine learning, ICT concepts, corporate solution development, and project management. He has a passion for AI factory and its application in business, which will be the Industrial Revolution 4.0. Over to you, Amelka. The virtual stage is all yours.
Hello, good evening, everyone. If you are joining Asia from Asia, then if you are from Europe and North America, maybe good morning. So, am I audible there, Shubhi?
Yes, you are audible.
Okay, thank you. So, I'm going to minimize the poll and going to hide the meeting controls. Okay, I'm not going to enable my video because the way I'm going to conduct it's more suitable for the way that I'm going without video. So since I have seen that all you have seen that what's the experience level that who have joined this series, but even though you are 10 plus years experience, even though you are a new beginner, the way I conducted it's suitable for everyone because the problem that I am going to explain, the solution, the business case that I am going to explain or share with you, what I have experienced is a real use case which is bringing millions of revenue to the client that I have developed this for. Not only me, that actually all the team. Then it's functioning well even right now, and we are doing operation and adding more things. So even being in the industry for 12 to 13 years at the time that we are building it, the cracking this problem was hard. So even you are experienced, even you are a new beginner, this session will be helpful for you. Before that, let me introduce myself that I'm from Sri Lanka actually. So maybe you have heard so many things at this moment due to the economic and political situation. I have graduated in 2007 as an electrical and electronic engineer, not from data science. I started my data science journey in 2010. So it's an honor to mention that Analytics Vidhya and the other MOOCs from the data science, central, super data science, machine learning mastery, Coursera, edX, all these platforms, including Analytics Vidhya, has helped me a lot to be a self-learned or self-studied data scientist. So then being in this DataHour, if you are a new joiner, if you are experienced, you are at the right place because I can mention that very well. So I remember that some of the use cases I actually implemented for the clients were extracted from Analytics Vidhya articles. So get so much thing out of it. So it's an honor now I am being a speaker in Analytics Vidhya after some years. So I will share all the knowledge. So this session is not a teaching session. This is sharing what we have done for a client and how we have break down the system. Okay, let's we move into the first slide. Okay. So think about this DSAA means Data Science Advanced Analytics. So you can see project component is highlighted or it's in a different color in italic mode, then what is DSAA project categories? So this is very important. I will tell you what, uh, because the way I'm going to in one category, that's why it's going to be very important. Okay, mouse pointer, take a different color. Yeah, blue is good. So project, we all know in the project management, it has a type, right? It has a definite cost. Time is start date, end date. So then we have a scope. So this applies for the DSAA, Data Science Advanced Analytics. So now the what I have mentioned below is I'm not a university professor, the kind of a person who wrote books. So these are some kind of high level categories that I have put it. So don't take it granted, but maybe kind of a way that I would like to put in. So we have a project, learning project. So maybe you take a course in a different online platform. So that's a learning perspective. Kaggle competition, analytic Vidhya data hackathon, analytic Vidhya course, and even this one. So this one as a learning project. So we have a very definite time, okay, 1 hour, cost, this is only the time cost, opportunity cost, and the scope. We know that the data, this is social network analytics. So R&D. R&D is about we have a kind of idea what the problem we are going to tracking, but we are not sure whether output would be what look like. So could output could be that this solution cannot be cracked at this moment because we don't have enough tool knowledge and everything. So R&D project also have a time, cost, and scope. Academia, think about a PhD for 3 to 5 years time, cost, time cost, and even if you are going to abroad in a different university, and also scope. So maybe defining the data science scope. This is everything related to data science scope. It will take 6 months to define a research problem, right? So these three are not I'm going to talk. I'm going to talk about industry because I am from industry for 15 years plus years right now. So industry also has a time, very important, also have very defined cost and also scope. They are doing something very important, ROI. So this apply for the project that I'm going to talk about. So any project, data science, advanced analytics project, also bound to this time cost scope. Plus, when it comes to industry, it always have a return on investment. So they do not invest unless there is a gain after some time. So now let's go to when it comes to data science and advanced analytics. So this problem statement, the data sets that we are getting, how we are going to consume it also different to the different projects, right? So how it's going, problem statement in learning in course or not in any course in analytics, it's very defined. Okay, what is the whether this person is going to buy this particular product or not. Very simple. The data set is given. It's clean, maybe clean or maybe few impurities, but data set also collected and given for us. So we don't want to worry about it. And even the consumption is our knowledge. Maybe if it is a competition, some kind of prize, even hackathon like that. R&D again, problem statement, we know that once we are going to crack it, data set, yeah, maybe we have to go and collect it and we have to spend some time, money on everything. Consumption, definitely output will be whether we can crack this problem or not, and if we are going to crack it, how it's. Academia, again, problem statement, we will spend 6 months, sometimes 1 year to define our problem statement very well. Data sets, again, maybe we are paying for the people to label data set, collect it, and like that. Consumption, either it's a PhD thesis or research papers like that. Now, this is my what I'm going to talk about, industry. Problem statement definitely coming from the internal clients. Internal clients means if we are a data scientist, our or the people or the business units coming for us are our internal clients. So business units coming for us. They are coming with the problem statement, but not in a vague manner. So they even don't know how to define it in a problem statement, which suits for data science and advanced analytics. So we have to define the problem statement, the data set. So based on the problem statement, we data scientists or we analytics people has to define the data sets. And the consumption is the most important part. If we crack the problem, if we get an output, How do you going to consume it? So this is very important for the problem that I am going to talk about right now. Okay, I'm going for the next one. So here the business requirement. Now maybe it's too much text. Don't read it. I will read it for you. So this data scientists are us actually. So the people who are joining here. So business user our internet client. So business user comes and says, "Hey buddy, as a MNO means mobile network operator. You know that who sells mobile connections and TV and broadband connection, fiber, likewise. Hey buddy, as a mobile network operator, I would like to identify the households. So what is this household? Household means people live under one roof of our customer base. So let's assume this particular network is Reliance, just for because most of the Indian, I believe, Asians are Indians. The Reliance have its own customer base. So now we want to know this customer base, is all these mobile connection, TV, and everything, are they living under one roof? That's a household, right? So now they want to know households. So now this is the explanation that this for the business problem that given by business use. Now data scientists that ask now going to ask some of the questions to define the whole problem. Why do you need to know households? Question is asking, why do you want to need it? Why do you want to need to know? So I mean that's very important when we define the business requirement, because based on all this requirement, what we are going to do, what are the features we are going to collect, how we approach the problem. So what is our output would be like different. So this is the question normally I have seen junior data scientists, people who are joining in the and even experience normally doesn't ask, because data scientists sometimes more like to do technical stuff. They want to do state of the art, including myself. That we have that tendency. We love technology and everything. So we want to know before. I mean, we when we said household, okay, I will go and define it. But don't do that, because I have done this in history. I will tell you some examples as well. So we want to know, why do you need to know households? Now I tell you an example. Without asking this question, how I have failed in maybe decades ago. So there was a requirement that they want to know who is going to miss the next payment for a loan. So this particular bank came to us and said they want to know, based on the payment pattern that they are doing for every month for a loan, they want to know who is going to miss the payment. So we didn't ask, why do you want to know? Why do you need to know the payments are going to miss? What we did, we built a very nice time series of LSTM model based on their patterns and other practice. We predicted, okay, this person may be going to miss next payment with this percentage. Now, then once we going to implement the thing, okay, now I know that this person is going to miss it. What we are going to do? Are we going to call them, sir? I know you are going to miss the payment. Don't do that. We can't do that, right? Because there's no action out of it. So there's no, we didn't ask this question. Why do you need to know the households? If you don't know, we actually don't know what this business user is going to do it. Even maybe he hasn't thought best of all. Now, let's come to the BU. What is he going to answer? That's exactly what they have given. Look, we do have household products. What is household product? Does mobile network operator have household product? Yeah, Reliance has it. Yes, they said home broadband, TV, fiber. They are not the people that who sell SIM anymore. They sell household products. People share this connection, right? TV is for household. Father sees it, mother sees it, the son sees it. Home broadband, we share the connection. Fiber, same. Even Netflix, there are 4 profiles. We share each other, husband, wife. So they have a 2 profile. Their tastes are different. So those are the household products that can sell to households. So without by knowing who live under one roof, they can do optimize their selling proposal. So they know this house does not have a TV, and we have a high chance because 7 people are living there. So likewise, they have a household product. They want to know who are living under one roof. Now we ask another question. Once we detect the household, so we know now why do you need it. So if we detect the household, how do you plan to consume it? Very important. How do you going to consume it? Because our output will be formatted, will be defined based on how they are going to consume. So business user said, tell me the households who are belong to that household. So what is the household and who is living there under one roof? What are the connection? What are the members? What are the national ID numbers or the social security numbers? Likewise, tell me the information and attributed detected for household. What is the purchasing power of this household? How many products is in this household? What is the geographical area? Are they in the city? Are they nearby road? Likewise. And what are the products that we can sell? So tell me some, give me suggestion as well. This house doesn't have a home broadband, 5 people living, already mobile packages are being used for data packages. Can we promote a home broadband because we think that they do have appetite for this one? So let's inject this information to their sales channel. So door-to-door people using some app, then the outbound calling call centers using outbound call. The people who used to call and try to sell something, they do have their application. So let's inject this information to sales channel. So now we know exactly what we are going to work in. So now you can see, or no, actually we can see just giving the this one and going back to the drawing board and working with the computer doesn't work unless we know whole picture. This business users, even you are a vendor, even you are internal clients, external clients, try to dig as much as we can because business users sometimes get an idea when they brush teeth in the morning and come for a data scientist as granted. Why don't you do that? If you don't ask this question and form the problem, even you are a beginner, even you are an experienced guy, it's not going to work. That blame will come to data scientists because it's our responsibility. Whoever comes, if you're going to develop something, we need to know in and out. Okay. Now, now this business unit person came to me and or my team, and now as a technical team or the people who like to do build stuff, do coding, do mathematics, do some such stuff, would like to know, can we do this technically? So when I say technically, do we have a right tool with us? If not, we have to purchase it. Or do we know how to crack this problem? Or do we have the skill set? If we don't have, we have to send someone for a training, isn't it, right? Because we can't again, or if we don't have the skill, we said, okay, we need 1 more month to train someone, get it done, because this particular language that we are going to use, nobody knows it. Or we have a guy, we have to hire them. Likewise, this is technically feasible based on our current context in this particular business. Okay, these are the kind of a question that we had. What do we have? Our customer base. So we have our customer base and they are purchasing and their transaction, who are they are calling and what type of all this information with us, all the behavioral, psychological and all the geographic information with us. So expected outputs, group them into household. So 5 people, this household, and this household is look like. Likewise, this is the output. This is a very important question. Okay, guys. The team, even you are a power user, even you are a new beginner, this is very important when it comes to industry. Industry doesn't want to build something from the scratch. If it is available in the market, if someone has done it, we are going to start from there. Either we are going to purchase license and get it solution, or we see, okay, if they have done it, definitely we can do it. And because the building it ourselves may be more efficient or maybe cheap, or maybe it's proprietary. So likewise, we want to know, has it done someone before? In this case, our team has conducted, are there vendors who are claiming that they have done this? And we did some literature review. We know there are so many MSc students, so many PhD guys, so many guys writing their research article. Maybe someone has touched this information, or maybe a white paper. Maybe someone who shared that we have done this, guys, do it, it's amazing. The articles, analytics Vidhya, definitely. There are so many content in this one. I have used it for a different application, not for this one, but I have used. And even dataset, Kaggle. I'm not just pointing some names, but as a data science community, there are things. So vendors, I have conducted, then we found there's only one vendor at that time. Now there are vendors, including India, Asian guys, claiming that they can detect household. But at that time, only one vendor was claiming that they do have it. We wrote to them. We wrote them because we are looking this solution. Can you come and explain whether your solution is work for us? This vendor is a Dutch vendor, Netherlands. They have done it for Europe. which is mobile networks are sold as a contract. Because of that, they do have a very high quality addresses. You know, in Europe, everyone has very clean addresses. All documentation were very well like this. In here, in Asia, most of the markets were prepaid dominant. Nobody has quality address. Even teenager buying their connection for their grandmother's identity numbers, ID documents, likewise. So this is not quality. So then the vendor and we all realized that the solution they did have is not going to work for us. So now we did the literature review and articles. We gather all the information. We decided, okay, based on our searches, that this problem can be cracked as a community detection problem. What is community detection? We are detecting a small community. Facebook, LinkedIn, doing this one. So they know that who are their friend circle, who like their post, who are sharing their post, who are reacting, who are making angry face. LinkedIn, same, who are messaging each other, who are calling each other in Facebook. So they know who is this community, and then they know if A person likes friend with someone and B person friend with someone, the A and C can be send us friend suggestion like that way. So it is a community detection. We want to detect a community. So now we identify, okay, there is a way to crack this one. So let's do it. Then question is, what is community detection? So we know that community detection, but we want to know more. Let's go to the community detection. So don't pay attention for the text that I have put it. Community detection in a social network. Okay, now we got another name. Look, social network. Social network is not social media network. Okay, this is not Facebook, this is not LinkedIn. Social media is the Facebook and WhatsApp and all those things. WhatsApp circle, likewise. Social network is there are entity or nodes, and there's another node, another entity, and they have a relationship. Like this is the social network. So when we draw it for a different context, it forms this type of huge network. Some are related to each other, some are just isolated, likewise. Now let's dig deep in social network. In social network, let me draw the social network for this context, which is mobile network operator. Now, mobile network operators, the entity is the connection. Connection is the SIM, right? SIM is like this, isn't it? And we know it's a dish TV. Okay, dish TV. Then it's a broadband, right? So these are called nodes or DS. So these are the entities. So in this problem, it's like this. So the relationship is called edges. So this is the relationship. They have same address. Okay, nice. These guys sharing same social security number on national identity card or the identity. Let's say ID, right? And there's another thing. So this, let's say this person is a spouse of the other mobile connection. So they do frequent callers. Frequent callers means call each other. Okay, remember this is a short mobile network operator social network related to the household, right? A home. This case home. So like, okay, these people are again identity card. Okay, these do have same address. So likewise, this is a network that we are interested in for mobile network operator for the home detection. So this is simple social network. Different application has different social networks. So the entities or these nodes called this one calls node, relationship is called edges. This is the vocabulary. Now let's go through some of the network just for the understanding what is social network and this one. So okay, experienced users, power users stay here because at the end of the day, near the end of the presentation, I am saying some of the information that was actually the problem was not hacked because of those things. I will tell you what those and maybe then your thinking pattern will be changed. So this is a 34% karate club network. The people communication with each other, friendship network. we can see two very important nodes. So then we know this, then we identify this is the instructor, this is, I think, his sub instructor or the helper. So with this one, we can say there's a high chance this network can be broken. This guy start a new institution. This guy might start a new institution. Very high likely, right? Then this is email communication. So who send emails to each other? So we can see these may be bosses, immediate supervisors, and others are maybe edge developers or maybe individual users. So then here we can say if someone inject malware here, there's a high chance it can be propagated to the other people because these are connecting with the emails. So this is again 2,200 people friendship network. So here it's a 436 HP employees. Okay, this is this is a network of direct flights around the world. Can you say what are the nodes here? What are the edges? So here nodes are airports. Edges are the routes. So now we know if someone attack here, there's a bomb blast here, how effective is the whole routes, whole flight journey. So they have to again reconverge and optimize. Okay, what is the alternative airport we can use? Okay, we found this Ebola found here. How many flights has come? What are the areas that we need to consider? So these are some of the use case. This is a simple network railway station. So what is the node? Station. Edge, the route, right? Then we know that if something happened here, so how it's going to break. So this is about human mobility. The people who have moved based on the dollar bills. So dollar bills is something that you can purchase here, spend here. So we know that this is again maybe a very good use case for the COVID type of thing. So someone who has their eyes traveling like this, so we know where we need to put the current. So these different applications. This is the people who are reading different political contents and how they are communicating with each other. We can see there are huge separation from the left wing and right wing. We know this has happened a few years back in USA. They have identified because of the social media. This time, social media, this separation is getting worse and worse. People stopping communicating each other. So none of the Republican want to speak with the Democratic. Likewise, digital division is getting high. So these are very important currently in Sri Lanka situation. If someone analyze Facebook, we can see okay why people are getting angry each other. Sometimes they are losing their ties. So internet connectivity. If something happened here, out we know that how many people are going to offline. So Wikipedia articles. So this is a protein to protein interaction, very important in drug related stuff and medical one. So here we can see if this one extinct, we know this will has to go extinct definitely because this is a very simple food chain, right? Food web. So now you know that what is social network, simple relationships and entities. So very different application. Now mobile network operator in our case. So now we started brainstorming with business users. So we identify what are the relationships that we can thought of uh, related to the home detection, household. We know NIC is Sri Lankan context, this is ID. So someone who is preparing have their national ID when they purchase a connection. Okay. If someone have a two connection with the same ID, we know it's belong to one person. Or we can decide. I mean, we can have we know there's a relationship. Then address. How equal these two addresses are. So we have built the NLP model here using different techniques, phonetics, and how letters look like and how it sound look like. So address matching model which say okay these two addresses, address 1 and address 2 are equal 90% computers likewise. So address matching. Then the frequent caller, whether they are calling each other every week 5 calls minimum, likewise frequent caller. Then the contact number. Contact number is something that when we buy a new connection, they are giving a this is my alternate number. Or maybe if they are making a complaint, okay, hey, I have a connection issue. This is my contact number if you want to reach me. This is a contact number for the complaints and when they purchase something. Self-care. most of the mobile operators have a self-cap. You can put multiple connections there. So we know that if that particular connections are in one self-cap, we know there's a relationship. We can't say they live in one home, but there's a relationship. In the device swapping in Asia and in Sri Lanka also, we swap our mobile sometimes due to some kind of very experiment, different things. We take SIM out and put it in another phone, and sometimes back again putting in the like, so device swapping, the mobile device swapping, we can form a relationship there in the mobile money. Can someone transfer money to another wallet? Can one transfer their excess data to another one? So likewise, the transfer. So we are forming so many relationships here. So these are relationships. Now think this is a mother, this is a grandfather, this is a father, son. They do have a different type of relationship. This is a one house, right? Even though they are living in a one house, these people have a external house relationships as well. So this person, maybe son having a connection with this uncle, device swap. They have swapped their mobiles, and due to some reason, they are living in a different houses, but they have a relationship. Frequent call. Grandfather calls this father, this house father. So now we want to break this one, right? That's our target. That's the community detection coming into the picture. So I will come to this one. This is what I said. Even you are a power user, even you are a very experienced user. This is the pivotal moment of this whole project, how we can crack the solution. Now let's go to the tools. So we have identified what the business problem is, how we are going to form the relationships, and most of the data is being collected, everything is there. Now what are the available tools? So there are different libraries people have developed for different algorithms, for different implementation, same algorithm, different implementation, there are libraries. And we found that there are even not only libraries, different databases as well. So GraphDB is a way that we can save a social network in a very easy to consume, very easy to query, very easy to compute, because the GraphDB is totally different to the transactional database. Right? Normal SQL database is totally different to the GraphDB because they are relationship like that. So even these nodes have attributes. This one age, let's say 26. This one is black color, and their relationship is they share same apartment, and this one is white. Likewise, so this information should be also fed in. So GraphDB is also there. So now we take the tool set that available in the market. Some are open source, some are payment, licensing, some are actually work well, but now nobody is updating. The GitHub repo is not updated very long time. So we know that even though we use it, it is not going to be long run feasible. So these tools are very important because these are like vehicles. So some tools like Formula One cars. So everybody can't drive, right? Even though drive, they can't get the maximum out of it. Some tools need expertise. Some tools like Toyota Corolla and so very generic vehicles, the most available vehicles. So these tools or these vehicles are made to be driven. So otherwise they can't sell it. So these tools, don't worry, don't be afraid. These were made to be used. So even though the different purpose is there, they were built to be used, so we can actually use it even if we don't know. With reading some documentation, couple of days, we can be expert. So these tools, never ever afraid of it. Anyone can start. It's like Excel, right? When we started during the first day in Excel, maybe someone doesn't know how to close it and how to, what is sale, how we can put a formula. But after some time, everyone used it because these are built to use. Because of that, those are sellable. So these tools, let's say there's a vehicle is Tesla. So Tesla is built in different purpose. It's eco-friendly, not to use fuel. So likewise, when we select a tool, we have to get why this tool is being built. Is it for big data? Is it for desktop computer? Is it for prototyping? Is it for production? Is it Python? Is it R? Likewise. So we want to know, select set of tools that we can use for. So we have done that activity. Then the community detection algorithms. This is very important because even tools are there, it should support our business problem, community detection. So we want to know, break these communities, right? We want to know, break these communities. So these implementation should be there. So we did what are the available algorithms, whether they have implementation on these libraries, these tools. So that's we did this activity. Then we found a set of tools already having set of algorithms. Some are having one, some are having two, three, some are totally different approaches. So we selected these algorithms and tools. Then project formation. Now it's time to form the project. So we pick the people who has the ability, who has the skill set, who is actually like to do this project. Someone doesn't like some project, right? If someone okay, this is an image recognition, face recognition problem. Some doesn't like image, some doesn't like anything, some like fully on transactional data, like that. So we found two data scientists we onboarded, and also BU guy who want to because we don't want to turn back because we said, okay, this approach is not working. Why don't you consult us? So in the beginning, we form a team. Then we assess what are the tools and are there any licensing code? What is the computing resources? How many hours we needed? Because if this is going to be AWS, GCP or somewhere, we know that pay as you go. Then this is very important. They need this output in 4 months. Either it's quality or not, we need to in 4 months. So we need to complete in 3 months. Then do the A/B testing in a 1 month. A/B testing means we want to know control environment, how our output is right now. Now, story of the project journey. So this is what happened. So now we select the tool, we did everything. Then we hit a big roadblock. That is, this social network is huge. Can you imagine in a mobile network how many connection, how many different type of relationship? Each connection might have 10 different connections, 10 different relationships, right? Huge. This cannot be even loaded into a memory, and it's taking hours to run the algorithms. It's huge. So this is big data analytics problem. So we have to run in a cluster. So all our tools converge into big data tools. So we selected Spark, graph frame. So graph frame is a library which can be used to do a community detection related stuff. Graph frame and also another implementation. I will call it later. So big data analytics is being used because it's huge. Second thing, now think about this is me, right? This is my boss. So we do not live together, right? Under one roof. This is my boss, supervisor, immediate supervisor. This is me. But we call each other because we work in office, right? So this means even though we form relationships, relationships contain noise. This noise is impacting our community detection process because this is not required for a harm detection relationship. So how we can remove this noise? This is very important in any data science advanced analytic problem. We have to think about how we can remove the noise. Any data point, anything that will add to noise as our project should be removed before we are running any machine learning algorithm or any approach. Because if it's possible, otherwise we can't, right? One thing should be, am I audible? Because I feel that I'm talking alone. Can someone make some noise here?
Yes, Samalka, you are audible to us.
Okay, thank you. And hope anyone not falling asleep, right? Only because I can't see anything. Okay, so we have to remove the noise. So how we can remove noise? In this case, immediate supervisor living in Colombo. I'm living in Kennedy, for example, if you know Sri Lanka. So how we can remove this noise? So what we did was, we want to remove the noise from our huge social network. We did the location information. We build a digital fence for this guy based on their tower location. We know every mobile having a tower. Even we can use administrative information, right? If it is in a Kerala, in this district, maybe, right? And this guy is in Delhi, even they're calling each other. Then we know these are living in a two different location. This is noise. So remember, this is the one of the very pivot, very important turning point of the project. By removing this noise, our output had make a huge quality improvement. So this is we call this location clustering. If you are going to implement in your network or anywhere, think about it. Even it's a bank, anything, if there's something not related to our context, even there's a data point, right? Nobody, data scientist has this kind of a tendency. They don't want to lose any data point. Try to use as much as data sometimes, but remember, to the context, we need to remove the noise. So we did that. Now everything comes. We have tried different algorithms. Do you know what happened now? Most of the algorithm implementation were to detect large communities. Large communities, Facebook, 100 people, 1,000 people, LinkedIn, 100 connections. So most of them are used to build the large communities. Now we start. Everything came nice, but algorithms detecting 100-member households. How we can avoid it? Now we go back again to the research and the things that we did. We did the research. Are there any algorithm that geared to build a smaller communities, 5 to 6 people, 2 to 3 people, likewise? Then we found there is an info map. That's a nice algorithm. The Chinese guy actually developed it. His research outcome. Info map is something like his implementation actually, as I remember. If you put some gossip here, or the information, how it flows through the network. This is how he has developed this algorithm. So if you tell something to your mother, how likely it go out from the house? It's less, right? It's always having the very close community, very small community. Now when we come to the info map, this didn't have a big data implementation. It's just a one kind of algorithm which run on a very small data set. Again, hit a roadblock. Again, we did the research. Then we found someone has changed info map into info flow. That whole algorithm make it to a discrete mathematics. This is a continuous or different mathematics, and convert it to a same mathematics, but sacrificing some quality. Implemented it for the big data analytics. So Hadoop environment, Spark. So everything was nice, and we get the output. We ran the A/B testing. Sales team said normally their conversion rate was 16 to 13, 16 to 20%. But with this approach, their sales conversion has improved to 60%. Imagine 16% to 60%. How many times? It's like 4 times, right? So huge increment, and people really liked it. And even not only that, because they knew that this type of area having this type of appetite, they are going with the with right devices as well. If you know that this particular area, there are a set of houses that can sell broadband, you are not going with just a leaflet. You are going with the broadband device, and you install it right away and come back. Like now, let's go to the okay. I will do a very small demo with the Neo4j. Neo4j is doing so much marketing for some time, and I use this one because to give you a kind of an idea what it look like. We haven't used Neo4j because we go for the big data one. Okay, Neo4j, I will show you the website and you can install and try it out. So this is the data set. Nodes are, this is a number, this is my label, and I put that is a mobile or TV or likewise. These are the nodes. Nodes means entities. Edges, this one linked with this one. NIC means Sri Lankan National Identity Card. In Indian and your context, you can put a social security or Andhan card or likewise. Then these are the relationships. Now, I have put into a Neo4j database. Okay, this is Neo4j desktop version. I have uploaded this data into this Neo4j desktop client, and it has a very nice UI version. So I enable this UI. This is the data set I have. I can see, look, it's very nice, right? This is a sample data set in a real case, because this data is real. I have built this for this use case or this demo based on my number and my friends, my neighbors. I did it for the real use case. Okay, this one maybe, okay, he's connecting with someone. It's hidden because showing all the information may not work for this UI. So we can see this is a node, address with my spouse number, then frequent caller with my mother, and then frequent caller with a spouse, someone, maybe I don't know what is it. Then this is my TV. Then it is same NIC, same address. So likewise, these are the relationships, real information, but kind of a demo version. So this is that how we can see this information, and we can see it in a table manner. This is a Neo4j. Now you can see the way that we have looked at data previously in a table manner, in a JSON manner. This is totally different, right? Totally different relationships manner. So how I connect with Subi connected with analytic Vidhya. Analytic Vidhya team connected with someone else. So this is the way that we see the data, the way that we can form a problem, a different type of problem formation can be used here. For example, let's say this is me. Sorry, Subi, I'm using you as an example. So this is Subi, and we have a kind of a Facebook or LinkedIn relationship. Now I am looking, let's say, to buy an inverter because we have a power cut here. And maybe, okay, this man, my friend, they might teach talking and having some kind of communication about inverter. If he's looking at inverter, Amazon can sell, can promote inverter here. Now look, this relationships kind of thinking pattern has changed the analytics way that we can think. This is the one method. Okay, now now we can see there are different relationships. What I have done in our real case as well, addresses we have given, because address quality was very poor, we have given weight for them. Addresses has 100. No, let's say address has 50. Same identity card had 100. So we have given weight for every and this connection. Then we know that how thick this relationship is. Maybe it's very small or maybe it's very thick. Likewise. So this is the weight that I have given. So imagine now we are making this problem more and more home detection, that context oriented, right? We have to make this one. This is iterative process. We know data science, we have a crisp DM, likewise, blah blah. But this data scientists always think differently, right? I'm not. I mean, others are not thinking. This is very important. So we are giving the weight as well. How confident that the relationship and how important it for the perspective of household detection. Okay, now we have done this one. Now I'm going to close this one. Now, to do the community detection for one specific algorithm, I have to aggregate this one. I'm going to start this DB because this is a desktop version, kind of a prototype version. It will stop another one and start in this one. You go and check on your 4G and its implementation, Neptune and different DB open source DBs are there. The tool set that I have different open source DBs. So guys, look at it and you can choose whatever you want. I am not marketing Neo4j here, but I am using it for demo purpose because I feel that it's easy to demonstrate. Okay, let me give you a few minutes to come it up. So what I have done here, I will show you that as soon as it's come up. So guys, hope you can understand what I'm saying. Even that doesn't matter. Maybe you will listen getting some new words, new ideas, then which may help in the downline, in your career. So I have happened to say, sometimes I'm joining into the webinars. I didn't know sometimes if it's doing in a different manner. I'm listening it. Then this might help in some time. Then I coming back to the webinar, they are recording and checking it. Okay. This is aggregated version. Let me show it. So if you can see here, now it has only one connection. What I have done is this relationship. Okay. I have sum up the weight. So this is the weight and this is the connection likewise. So then based on the documentation on the Neo4j, what I have done is I have ran these commands. This command. Okay, I have created this graph. Let me run it just for the fun. Don't think it's don't think about this command. Okay, it ran. I'm not sure whether it's giving an error because I have ran it before. Okay, it's ran. Then Okay, same thing, right? Same one. So then I am running label propagation is a algorithm. Remember, it's an algorithm, community detection. I'm going to run it. Let's see what's going to happen. Uh, Maybe we are getting an output. Okay. It ran and it gave me, okay, there's a community detection, different set of communities. These are the community number. Look, these houses are grouped, these numbers were grouped into one connection. These are into one connection, one group, community detection. Then I'm going to write that information back to the DB where I can demo it later. Okay, they have ran several iterations. They have detected 30 houses. Let's say like that, 13 houses or 13 communities. Now let me run a different tool. It will come. This won't take much time. I just want to show you. There's another tool called Bloom. Hope it is coming up. Okay. Until that, this is a very simple tool to do the demo purpose I'm using. But again, as I said, we have used big data related tool stack. That's a solution is a big data. But to build a prototype, I don't know, restock. Let's see. Okay. So this is another tool. What I have done is I have colored these community detected communities. So these three has detected as a one community. You can see, right? So these two is another community. Even though we have relationship, this is a different community. Remember this? Look, not remember. This is another community. Very obvious, right? Another house. Another house. Okay, here another house. These two. Hope you can see my screen, right? Subi?
Yes, Amilka, I can see that.
Yeah. Okay. Nice. I just did the demo. It's just for the elaboration purpose. Let's go back to the presentation. Okay. This one comes into the picture. Maybe now you might wonder, oh, these mobile network operators sneaking into my data and they know whom I am living with, whom I am calling with. Isn't this privacy violation? GDPR. I hope everybody know what is GDPR and what. So now in Sri Lanka, in my country, there is a privacy protected act has been passed. It is inactive, but different companies ask for a grace period for the implementation, including this client has to go through the GDPR. GDPR is a European one, but that type of analysis whether we are violating someone's privacy. So after so many analysis, so many things, we have to change the different type of tweaks, and then what we have done is, okay, we are not violating your privacy. We identify what we can sell for you. That's all. Nobody knows who living together. Nobody knows what the relationship these guys having. All those are hide. Only system knows. Only what we are getting out of is this person and this person can be targeted with this type of product because that's the kind of product enhancement. Uh, instead of sending so many different type of offers, we are targeting offers that may likely that will add value to their lives. Everything was secured. PII is not violated. So GDPR gate was passed. To take this GDPR gate, it took, as I remember, 1 to 2 months. There were so many discussions. Simply asking, can someone come and go for the court and ask a penalty? Look, these guys are sneaking into this. So that's been done. The only thing that we haven't addressed so far right now, which is we can't do it right now, which is that Sri Lankan organization has asked for a grace period. The amount of information that we are collecting to do the analytics, we have to get the consent. So we know that in Google or in Analytics Vidhya, we have the terms and agreement. So most of the terms and agreement we have run, the information that we are collecting, we are using for the marketing purpose, blah, blah. But in most of the mobile agreement, which has been sold a few years back, doesn't have that clause. New connections doesn't have it. If you have read it, you can see it's for the marketing. You have given the consent, right? Likewise. So this by being part now collected, once the grace period over, we can do that. Okay, the last slide. Sorry if I taken too much time, but this is last slide. References. I just want to highlight the applied social network analysis in Python, because as soon as if you are interested, as soon as it's covered, you want to start somewhere, right? These are two courses that I found interested, which I have also learned. Applied social network analysis in Python in Coursera. Again, not marketing, that I just want to share some of that here. And this one is in YouTube. This is very important. Machine learning with graph. Here they are talking about not only graph or not only social network, the deep learning. They're very important. The deep neural network, they call it now graph neural network, GNN. This is hot topic right now. If you want to read it, if you want to go and dig it, maybe it's giving so much things that what we maybe I'm applying the graph neural network for my use case, or the use case that I expect could be given tremendous accuracy improvement. So we are now trying it. That we have allocated one resource. Do I that the R&D project? Remember, this is now we call as R&D. We want to try with graph neural network. Give us some. We requested 2 months for 4 sprints actually. Yeah, 4 sprints to try with the graph neural network. If outcome is very interesting, then we will go with that implementation. Okay, that's it. Thank you. Now over to you, Shubi.
So
Uh,
thanks, Emilka, for such a wonderful session. Um, Now I have an announcement to make. Before we proceed to answer your questions, I would like to request the attendees to please fill in the poll about feedback, as it helps us to conduct more such sessions. So, Emilka, now we can do the Q&A.
okay, let me open it. How did you do that graphic? It's inbuilt. It's a tool, simple tool that these graphics. Okay, there are tools, libraries that we can code it and get the visualization. But this tool has an inbuilt graphic. There are so many tools that can be do. Is it similar to knowledge graph? Okay, feedback full. I'm going to minimize it here. Is it knowledge graph is another graph, right? How we can graph it? Again, it's a graph, but always it's context dependent. How is Neo4j for graph analysis compared with a shown tool packages? Different application, different complex, different tool set. Neo4j suit for something, Neptune suit for something, open source suit for something, Infomap suit for something. As I explained, different tool suite for different purpose. So there is no one stop solution for anything. That's why I said we did the literature research, we collect so much tools into our list, and we did the analysis. What is best for us, for our context? We take us out, filtered several into our bag, and we try. And when we go into hit roadblock challenges, we found that this tool is not going to work. Okay, data science is an experiment, right? You are like having a court and doing experiment in a lab, likewise. Sorry, I'm lost. I want to know what's the purpose of using these tools. Could you? Tools are actually that Python is a tool. Very simple. Python is a tool. So likewise, these tools someone has built that other people can start using it for their, like a knife. So we don't want to build a knife to cut our vegetable, right? If you want to cut vegetable, we buy it, we take the knife, cut it. Likewise, how we can use SNA tools. So every tool has a documentation. This is not, I mean, every tool has its own syntax or its own way of using it. Simply, I'm just requesting you can go to the documentation. Those are very easy. Again, tools are like vehicles. If you know drive one vehicle, it's easy to convert for another vehicle. Do we have some hands-on examples? I mean, in terms of coding etc. So it's again, you can find the data sets, maybe Alex Vidhya, maybe Kaggle. There are so many data sets that we can represent data in a social network with, and we can do form our problem in a social network way, as I said right now. Very simple. I involved in 2020, as I remember, during the COVID time in Sri Lanka. They want to know at the very early stage that there is a quarantine measures. You know that if someone can infected, all the people were taken to the quarantine centers. So I was invited to implement a solution based on the mobile data by the government, and they want to know if someone is affected, can we identify a cluster where they are contacting. So we are using the same social network analytics. What exactly is noise in the context? This noise is a relationship which is not representing the valuable information for a home. As I said, myself and my father living in one home, our relationships are valid because we are living in a one geographical area. Me and my boss, who is living in a different geographical area, but we are having a frequent caller relationship. We are calling each other. We having that relationship doesn't add any value to our home detection. That's a noise. If we can remove that relationship based on our geographical location, we can do it. Then how do you apply machine learning, deep learning in graph? Go and read graph neural network. There are so much thing in different blogs and different places. Are we not using Python here for M? We have used Python, actually PySpark, not Python, PySpark in the use case that we have implemented for this particular client. Can you share the data if it's not this data? I built it myself for this demo purpose. You can find there are so many data sets available in different repos. Just do a Google search, you can find so much data. What are the uses of social network analysis that I have exactly mentioned that different purpose. This here, household detection, who living in one roof. In a COVID situation, who contacted. In a bomb blast situation, which airport we can use for reroute this one. In a railway network, if something is going to happen, how we can route it. Likewise, different application in Facebook. This is used for marketing. You are getting friend suggestion. You are getting different content suggestion. You are getting different type of thing. Social network analysis is heavily used. How much data needed for entire products? It's depend on again the context. So in our case, it's whole customer base, which is millions. In different cases, like let's say you want to analyze how email being communicated because you want to identify malware spread, then it's the size of the organization people, right? It's a 1,000 member organization. What are the application of this and where most useful? This is being used heavily in most of the places right now because this new approach. Again, I'm saying it's a social network analysis plus another one. Likewise, it's a combined approach. There are so many use cases. Just Google it. You can find so many cases. Can you mention tool suitable for DFA? This is I'm not getting it. Can you integrate pictorial data into it? Yes, I have seen this one. Even conventional neural network, that it's a kind of it's represented in a social network way. I have read one article, but I am not sure how it has been used. But there were different. Let me tell you a very interesting use case that I have implemented using social network analysis. That's a very well celebrated case. Is fraud detection. Imagine someone is doing a fraud. Let's say it's a black money. You are whitewashing black money. You are injecting black money into the financial system. Then the financial transaction were put in a social network, and you can identify who are doing the fraud. And drug deals. If someone is doing a drug, selling drugs, and their transaction coming all over the place, we know who is doing it. So fraud detection is a very, very well celebrated cases in social network analysis. And not only that, they are identifying who are the very key people in a different business context because those are the influencers, the central people. If you can attack that person with some kind of propaganda, it can be spread into so many people because there are so many followers. Let's say you want to do a political campaign, you have to identify okay, there's a kind of a religious guy who has a lot of fan base. That's simple social network, right? And if you want to do it automatically, if you don't want to digital way, that's been used. So that's how it's been. How to do it.
Hello, Milka, you are not audible to us.
Do, I mean, 50% of your coding, 50% if you're learning doesn't work. 80% of your research methodology, 20% of your coding and getting that stuff. Remember that for me, MSc research is to know how to do a research actually. Maybe my voice. Subi, are you there?
Yeah, now you are audible.
Okay. How many minutes that I was not audible? Hope I went through.
It's okay, you can continue further from here.
Okay, I think I have. Okay, let me go to the last few questions. So, can integrate pictorial data into it? Yes. There's that the whole way that we put into data into a database is different in a social network, different into a transactional database, different into a NoSQL database, different into a blob storage. So different. So we can do that. I have seen so many articles that how they frame the problem in a different way. So MSc research, again, maybe if you haven't heard me well, MSc is research is not to mainly do a research, actually to learn to how to do a research. So if you're selecting a research problem, select it 80% of your time will be spent on to learn how to conduct a proper research. Do a literature survey, write it very properly, research methodology and research setting, everything, right? Then 20% is actually you are doing the coding and conducting the research. So if you select in other way, 80% of your coding, 20% of your writing, that's not our purpose, I believe. So I think I have answered all the questions, Hubi, here. Yeah. Chat is okay. Thank you, Zubi. I hope someone gets some at least some the time that they have spent valuable. So any more thing, any more question, any more I can take?
Thanks a lot, Amelka. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct some more sessions with you in the future.
Okay, thank you. Actually, it's an honor to doing a session on Analytics Vidya. As I said, I have heavily used this one in my past. I learned a lot, and I am maybe being a data science, Analytics Vidya has a part of it. Thank you, guys.